Okay, this is section 2.6, special angle pairs. So first definition is transversal. Okay, what is a transversal? It's a line that intersects two or more other lines. Okay, and it's got to be in two different places. So right now, if we look at this example that I have, okay, then line M would be your transversal because it crosses line L and then line N. Okay, and so then if I change it up a little bit, if I maybe have something like this, now we have line N is our transversal because it intersects line M and line L. So it can be interchangeable, okay? And then what if I do maybe something like this? Okay, if I do something like this, well, then now you have all three are transversals because they intersect both lines. So L intersects both the other two lines, N intersects lines L and M, and so they are all considered a transversal in something like this, okay? So a transversal is a line that intersects two or more other lines. Okay, the first special type of angle pair that I want to talk about is corresponding angles. This is when two angles are formed by a transversal intersecting two lines, and let me get my highlighter. They lie in the same relative position, okay? So that's the easiest way to put it, all right? They lie in the same relative position. So if you have different colored pens, now would be a good time to use those. So for instance, angle 1 that I just colored in blue lies in the same relative position as angle 5. You see how they're like in the top left corner in each intersection? So angle 1 and angle 5 is a pair of corresponding angles, okay? 2 is in the same relative position as 6. Okay, so angle 2 is with angle 6. Angle 3 is in the bottom left, and 7 is in the bottom left. So angle 3 and angle 7 are a pair of corresponding angles. And then lastly, 4 and 8. Angle 4 and angle 8. Those are corresponding angles. So if we ever ask you to identify some corresponding angles, follow this definition and be able to identify them. The next special angle pair is alternate interior angles. Alternate interior angles are formed by a transversal intersecting two lines, okay? But these are going to be on opposite sides of the transversal, okay? So they're going to be on opposite sides of the transversal and in between the two lines, okay? So they lie between the two lines and are on opposite sides of the transversal. So where's in between the two lines, okay? So here's our transversal. Let's label that T. So that's our transversal. And so in between the two lines would be, let me shade it right here. See how this is between the two lines? Okay, so it's going to be angles 3, 4, 5, and 6. Okay, so let's identify those. They are going to be on opposite sides of the transversal. So here's 3. 3 is going to be alternate interior with 6. Okay, so angle 3 and angle 6 are a pair of alternate interior angles. And then the other pair would be 4 and 5. Okay, so angle 4 and angle 5. So be able to identify alternate interior angles and given any type of picture. All right, the next special type of angles is alternate exterior angles. So very similar to what we just talked about, but the only word that changed is the word exterior. So these do not lie between the two lines, so they're going to be on the exterior, and they're going to still be on opposite sides of the transversal. So remember, this is the interior, right? So we don't want to use angles 3, 4, 5, and 6. we're going to use angles 1, 2, 7, and 8. 1, 2, 7, and 8. So we don't want to be in the interior. And then we got to be on opposite sides of the transversal. So our transversal is that one right there because it crosses the other two lines. And so 1 would be paired up with 8 to be alternate in exterior angles. So angle 1 and angle 8 are alternate exterior. And then over here, 7 and 2 would be the other pair of alternate exterior angles. So angle 7 and angle 2. Next special pair is called same side interior angles or consecutive interior angles. So you might hear either one. Okay. So these again are formed by the angles are formed by the intersection of two lines with the transversal, and they were in the interior of the two lines, and they're on the same side of the transversal. Okay, so think opposite of alternate interior. So they're going to be on the same side. So let me highlight the interior again. So remember, those were angles 3, 4, 5, and 6. So those are my interior angles. And then the transversal is right here because it crosses both of the lines. And so they have to be on the same side of the transversal. So 5 is on top of the transversal. So we want to match that up with 3. So angle 3 and angle 5 are pairs of consecutive interior angles. Then the other pair would be 6 with 4. Those are also same side interior angles. So angles 4 and angle 6. 4 and 6. So be able to identify these as well. Okay, and then the next one is same side exterior angle, so kind of like what we just talked about, but on the exterior of the two lines. So these are going to be on the exterior of the two lines, and they're going to still be on the same side of the transversal. Okay, so here's the interior. Remember, it's angles 3, 4, 5, and 6. So we don't want to use 3, 4, 5, and 6 because we just said that they are going to be on the exterior. Okay, so this is our transversal. So I'm going to label that line T. And so 1 would be with angle 7 because we want to be on the same side of the transversal line. And so angle 1 and angle 7 are a pair of consecutive exterior angles. And then angle 2 is with 8. Angle 2 with angle 8. All right, so these are all special types of angles that you got to be able to just pick them out, okay, and identify them. So let's practice that on this next slide. So the crazy thing is about this picture is that all of them are transversal, okay? Line T is a transversal. We'll call this one line M, and we'll call this one line N, all right? So they're all transversals. So what I would do, that's when we went through all of these definitions, it was always just two lines and then a transversal. So if you get your hand, because you'll have one like this on your homework, if you get your hand and just kind of cover up one intersection, then you can kind of tell right now T is just a transversal, and that intersects lines M and N. And then if I cover this section down here, well then now line M is the transversal, and lines T and N are the two lines being intersected by the transversal line M. And then if I cover this section up here, then line N is the transversal that intersects lines M and T. So I'm going to use my hand to cover it up to help find some of these matches, okay? So let's see, we have corresponding angles. One would be corresponding with, and you can cover up either one. You can cover up this one, and it could be corresponding with 5. You see that? And you could cover up this one, and that one would be corresponding with 10. So you see that? It doesn't matter which one we use. So 1 can be with 5, and 1 can also be with 10. Sorry, step backwards. 5 and 10. Those are corresponding. So actually, you should put 2 there, angle 5 and angle 10. So let's try 6. 6 is right here. So if I cover up this side over here, it could be with 2. And if I cover up this side over here, it could be with 10. Okay, so 6 can be corresponding with angle 2 if I cover up this, and angle 10 if I cover up that. So there's 2 different ones. So 6 can be with 10, and 6 can be with 2. So angle 10 and angle 2. Okay, so that's corresponding. Corresponding. So now let's try B, alternate exterior angles. So angle 12. So if I cover up this section right here, the alternate exterior of 12 would be with 4. See how it's on opposite sides of the transversal? Right? And then if I cover up this section over here, that could be with 5. So 12 can be with angle 5 and angle, what was that? 4. Okay, let's try angle 8. Where's angle 8? If I cover up this section up here, it could be with angle 10. If I cover up this section over here, it could be with 2. So see, sometimes there's 2 answers. All right, so let's use a different color. So 8 could be with 2 for alternate exterior, or it can be with 10, depending on which intersection you cover up. So this could be angle 2 and angle 10. Let's try alternate interior angles. Alternate interior angles. So 2, angle 2 is up there. So if I cover this right here, okay, so if I cover this section right here, the interior angles are 4, 3, 5, and 6, not 2. So I cannot use that. I have to cover this section up over here. So in this case, it would be 2 with 9. And there's only one answer for that one. So alternate interior with angle 2 is angle 9. And then we have angle 11. So if I keep my hand covered up on the bottom left, notice the interior angles are 2, 3, 9, and 10. 11's on the exterior. So I have to go and cover up this section over here, because now 11 is in the interior. See, these right here are in the interior. So that would be with 11 and 6. So that one only has one answer as well. So there's only one alternate interior angle with angle 11. Let's try same side interior. Same side interior, angle 2 is same side interior. So let's cover up this section over here because 2 is up here. Well, now look, 2 is on the exterior. Only 3, 4, 5, and 6 are in the interior. So that won't work. So I have to cover up this section over here. Now 2 is in the interior. Let me erase these other ones. So 2 is in the interior when I cover it like this. So it's 2, 3, 9, and 10. Those are the interior angles. So 2, and we need it to be on the same side. So we don't want to pick 9 because that would be alternate interior like over here. So it's going to be with 10. So 2 and angle 10 are same side interior angles. And then what about angle 3? Angle 3, well, 3 and 9 would work. 3 and 9 would work. So those are alternate interior, but you got to check the other one as well. What if I cover up this section? 3 is still in the interior. So 3 can also be with 6. So there's 2 answers for that one that are alternate same side interior with angle 3. Okay, let's try the last one. So on the last one, angle 5 is same side exterior with what? So let's cover up this section right here. Okay, if I cover up this section right here, 5 is not on the exterior. You can see 3, 4, 5, and 6 are interior angles. So that's not the intersection I want to cover up. I need to cover up this one right here. So 5 is on the exterior now because 6, 9, 7, and 11 are in the interior. And so we need to be on the same side of transversal line in. So that would be 10. So angle 5 and angle 10 are same side exterior. And then the last one, angle 8. So let me get a different color. Angle 8 is down here. And same side exterior. Well, it's an exterior angle here, so notice the same side would be 12. So angle 12 is same side exterior. Don't forget to check the other intersection. What if I cover up this one over here? 8 is still on the exterior. So what is the other same side exterior angle? That would be angle 1. So that one has 2 answers. So some of these had 1 answer and some of them had 2 answers. And so you have to kind of just utilize covering up an intersection to kind of help do those one at a time. All right, so be able to identify all these special angles, okay? On this next investigation, we have a particular situation. We have some parallel lines now involved. If you notice on all of these, there was no parallel lines there. None of these were parallel lines. So something unique happens when we have parallel lines. So we're going to investigate that right now. So get your pencil and your ruler and go ahead and construct a set of parallel lines. So here's how you make parallel lines. All you have to do is get a ruler, hold it still, draw a line on top of it and below it without moving it, so that way they can be perfectly parallel. And then it also says to create a transversal. So I'm going to get a transversal like this. Remember, a transversal intersects both lines, okay? So there we go. We have a transversal. Let's mark these parallel because they are. And then it says label the angles like the picture below. So let's use those same numbers. 1, 2, 3, and 4. Kind of like earlier. 5, 6, 7, and 8. So it says place the patty paper over the angles 1, 2, 3, and 4. And then it says copy the intersecting lines. Copy the 2 intersecting lines M and L over the 4. Okay, so which ones were M and L? So let's go label that. So this would be line M, this would be line L, and this would be line K. Okay, so now I'm going to copy those. So in order to do that, let me group all of these together and actually just lock them down so they don't move. Okay, so now these are in place. And so basically a patty paper is like a tracing paper. So what I'm going to do is I'm going to get my highlighter and you're going to see I'm going to trace these lines right here. So there's that one. And then there's that one. Okay, so try to trace it as best I can. Okay, that's pretty good. That's close enough. So remember, this is angle 1, angle 2, angle 3, and angle 4. Okay, so now what I want to do is I'm going to group these together. Okay, so those are grouped together, and it says slide the patty paper down. Okay, slide my little tracing over the intersections of lines M and K. So watch when I slide it down. What happened here? It's exactly the same. So you notice angle 1 is exactly the same as angle 5, 2 is the same as 6, 3 with 7, and 4 with 3. Okay, so we have a bunch of congruent angles here. So let's go ahead and mark those because they're all the same. And plus you can kind of tell because it's drawn to scale. Whenever you have parallel lines, those are drawn to scale. So remember, angle 1 was congruent to angle 5. Angle 2 was congruent to angle 6. Angle 3, which is the same as 2, right? Because we just learned that those are vertical angles. So I'm going to put 2 tick marks there, but use the blue. But 3 was the same as 7. And then the last one, angle 4, which is the same as 1 because 4 and 1 are vertical. And we learned that vertical angles are always congruent. That one was the same as 8. So now this is the same number of angles of all the special angle pairs that we just talked about. Okay, and so now we're going to tie those two. We're going to tie those two together, the special angle pairs, with these congruent angles. So the first one, how did the corresponding angles turn up in this particular situation? So if I go back, the corresponding angles were 1 and 5, 3 and 7, 2 and 6, 4 and 8. Those were all the ones that I color coordinated. So when that happened, we're going to write this. Then if two parallel lines are cut by a transversal, then the corresponding angles are congruent. The corresponding angles, I'm going to use symbols, are congruent. Always, always, always. So here's another picture to kind of show that, okay? It's kind of almost like the same colors that we just did. Right? So only again, if you have, guys, parallel lines. If they're not parallel, then they're not congruent. What about the alternate interior angles? Were the alternate interior angles congruent? Let me flip back real quick. Remember, alternate interior was 4 and 5. Those are alternate interior, and I have the same tick marks. And then 3 and 6. So those were also congruent. Okay, so here's another picture of what that looks like. So we're going to write the conjecture. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, just like shown in the picture. And again, you have to have parallel lines. How did the alternate exterior angles turn out? Okay, the alternate exterior angles looks like this. Okay, so those were also congruent. So we're going to write down, if two parallel lines are cut by transversal, again, you have to have parallel lines. That's the key words. Then alternate exterior angles are congruent. Alternate exterior are congruent. Now these were different. These were different. Same side interior and same side exterior. So let me flip back to our example, this one right here. So the same side exterior, let me remind you, this one and this one are same side exterior. So clearly they're not congruent. However, 7 is the same as 3, right? Because those two are congruent. And what did you learn about angle 1 and 3? That's a linear pair, and therefore those are supplementary. So those were same side exterior. What about same side interior? That would be like 4 and 6. Those are clearly not the same. But again, 4 is the same as 2. And so how is 2 and 4 related? Those are another linear pair. So those linear pairs add up to 180. So when you look at same side interior and same side exterior angles, okay, then those are going to be supplementary. Supplementary. Okay, so in this case right here, if we're looking at the same side interior, that's 3 and 5. So angles 3 and 5, those two are always going to add up to equal 180. The other set of same side interior is 4 and 6. Okay, 4 and 6 as well will always add up to equal 180 because that's the definition of supplementary. Let's take a look at the same side exterior, 1 and 7. Clearly not the same. However, those are going to be supplementary because it ties back to a linear pair. So angles 1 and angles 7, those add up to 180. And then angles 2 and 8, those are also going to equal 180 degrees. Okay, so same side interior angles and same side exterior angles are always going to be supplementary, not congruent, but they're going to add up to 180. So how do we put that all in one conjecture? Okay, it's pretty simple. It says if two parallel lines are cut by transversal, then the corresponding angles are congruent. The alternate interior angles are congruent, because that's what we just wrote down. And the alternate exterior angles are congruent. Notice we didn't say anything about same side interior, so just those. Okay, and then the converse works as well. Okay, so if you see two lines cut by a transversal, to form pairs of corresponding congruent angles, congruent alternate interior angles, or congruent alternate exterior angles. So let's take a look at this example here. The 120 is corresponding to that other 120, and they're identical, okay? This alternate exterior is identical to that alternate exterior angle pair, okay? So when that happens, those are congruent, then you should know that this line is parallel to this line. Even though it doesn't look like it is, you should know now that those have to be parallel, because that's the only way that it worked out in our little investigation. It's just not drawn to scale, okay? All right, so let's try some examples. So find the missing angles. Okay, well, I have 30 degrees. The best thing to do, guys, is to fill out every angle you know. So I see a 30-degree angle right here, okay? And I know 6 is going to be 30 degrees. I know 5 is supplementary to the 130, so that's going to be 150. And then you just learned that since these are parallel, alternate interior angles are congruent. So these two are congruent. So that's also 30, which takes this to be 150. There's just a lot of congruent angles, guys. And then this is 150 because that's vertical. And then that's 30. So see, you're already solving for all of those just really quick. And then over here, we have a 90-degree angle. And then this is a different type of transversal over here. So don't think like, oh, if this is 30, it's alternate interior with 7, so that's 30. Incorrect, because these two lines right here are not parallel. It's the two red markings. And so if this is 90, then that has to be 90 because same side interior angles add up to 180. Okay? So 1 was 30, 2 was 150, 3 was 150, 4 was 30. This is the easy part. 5 is 150, 6 is 30, and 7 was 90 to go with this right here. All right, let's try another one. And so here we have a little bit of algebra. So this is 50 degrees, which means it's vertical with this one. So that's 5x minus 40. And then I need to solve for angle 1. Well, to solve for x should be pretty easy because this angle is congruent to that angle because they're vertical. That's what we learned on the last lesson. Okay, and you might have learned that in middle school. So 5x minus 40 is equal to 50. I'm going to add 40 to both sides. 90 equals 5x. Divide by 5. 5 goes into 90 18 times. So x equals 18. And then you want to plug that in, figure out. So let me go get my calculator. Okay, and then to actually figure out angle 1, I don't need my calculator. If I use the 50-degree angle, I can work from there. So if this is 50, remember this is the alternate exterior angle with angle 1. So those two are going to be the same. So angle 1, because we have parallel lines, alternate exterior angles are congruent. So angle 1 is just 50 degrees. Let's take a look at the second one down here. So we need to solve for angle 1 and angle 2. I don't know any angle measures, but I do know that this angle right here that I just colored in red is 12x plus 16. And this angle right here in red is 5x minus 40. Those are the same side interior angles, which what did we learn about same side interior angles? Is that they are supplementary. Okay, so what we want to do with 12x plus 16 is add it with 5x minus 40. So 12x plus 5x is 17x. Negative 40 plus 16 is negative 14. And we want to set that equal to 180. So again, all I did with those two is add them together. And so I'm going to add 14 to both sides. And then I'll get 17x equals 194. And then 194 divided by 17 is, oh, that's wrong. Rewind. That 14 did not make sense. Okay. So it's not negative 14, it's negative 24. So let's go fix that. Negative 24, okay? Because 16 plus negative 40 is negative 24. Okay, so let's try this again. Add 24. Good thing I caught my mistake. Equals, we're going to add 24 equals 204. And then 204 divided by 17 is 12. So x equals 12. So 12 is going to go right there. And so then now we want to definitely plug 12 back in to get an angle measure. And so I'm going to do this one down here. I'm going to plug in 12 for x. So 12 times 5 is 60. And then 60 minus 40 is 20. So this angle right here is 20 degrees. And so if that's 20 degrees, this one's 20 degrees. Remember, alternate exterior angles are congruent. And then since those angles are 20, this angle 2 is a linear pair with that 20 degree angle. Subtract that from 180, so that means this angle 2 is 160. So angle 1 is 20 degrees and angle 2 is 160 degrees. Last one. So we have 3 parallel lines, okay? And then this is a big transversal right here that I just labeled T. And so we have a lot of congruent angles here, okay? We also have an angle bisector right here that I just labeled B. That's an angle bisector because those 2 marks right here. And so we have to find the measure of angle 1 and angle 2. So one thing to consider is if this is x plus 20, then so is this. That is x plus 20. And then we have 3x minus 10, which is this alternate exterior angle with this one here. So that's one way to do it. Of course, there's many ways to do this, okay? This one is also 3x minus 10. You can consider this one as corresponding with this one. And so ultimately, right here, this whole blue angle is the congruent to this whole blue angle here because those are alternate exterior, or like I said, you can say this one here because they are corresponding. And so those are actually congruent. So this whole angle up here would be 2x plus 40. And you want to set that equal to 3x minus 10. Okay. You could also do this. This vertical angle here is 2x plus 40. And so then you have these two right here that are corresponding. Okay. So whichever way you figure that out to be, they are congruent. So I'm going to minus 2x from both sides. I'm going to add 10 to both sides. So then I get 50 equals x. Okay, so x equals 50. So now I want to plug that in to try to get the measure of each angle 1 and angle 2. So I'm going to just plug in 50 to the 3x minus 10. I plug in 50 right there. Then 3 times 50 is 150. 150 minus 10 is 140. Okay, so again, all I did was plug in 50 into x and that algebraic expression. And so that's how I get 140. Angle 2 is corresponding to this angle, so that is also 140. And then angle 1 is same side exterior with this angle 140. And so remember, same side exterior angles are supplementary, so that makes that one 40 degrees. So angle 1 is 40 degrees and angle 2 is 140 degrees. And I believe that's it. And that is the last example, using all these special angle pairs.